Hi everyone. Today we are going to discuss indeterminate forms part second. In first part we already discussed about what are the indeterminate forms or how many indeterminate forms. So there are 7 indeterminate forms, and what is the hospital rule we discussed in last session. So once again revise this indeterminate forms. So which are the indeterminate forms? So first one is 0 by 0 indeterminate form is there. Next one is what is that? It is infinity by infinity. Next one is what is that here? 0 into infinity indeterminate form. Next is there infinity minus infinity. Next is there 1 raised to infinity. Next is there 0 raised to 0, and the last one is what is that here? Infinity raised to 0. So these are the 7 indeterminate forms. 7 indeterminate forms. And if these 7 forms, so that in first part we discuss about the first two indeterminate forms. Means what is that first two indeterminate forms? So this is 0 by 0 and infinity by infinity. Now we are going to solve example on the indeterminate forms, that is 0 into infinity. Means 0 into infinity onwards we have to solve is there. But before that, what is indeterminate form, guys? So indeterminate form is that we have or studied certain rules to evaluate limit, guys. We studied a certain rules to evaluate limits, but some limits cannot be solved by using the rules, guys. So that type of limits is called as indeterminate forms. So we also called as indeterminate forms are advanced part of limits, guys. Advanced part of limits. So there are 7 forms are there. Now these 7 forms are in this way. Now we have to solve this type of limits. So L'Hospital rule is required. L'Hospital rule is required, and L'Hospital rule is only applicable for these first two indeterminate forms. L'Hospital rule only applicable for first two indeterminate forms. If we solve this third form, fourth form, and means if we solve third to seventh form, you have to convert all these types. You have to convert all these types into. We have to convert all these types into 0 by 0 or infinity by infinity indeterminate forms, and after that you have to use L'Hospital rule. Means what is L'Hospital rule is here? If limit as x tends to a f of x, it is nothing but here f of a, and that is equal to 0, and limit as x tends to a, there is another function I am going to discuss here, g of x, that is equal to x is replaced by g of a, and that is equal to 0. Then means here f of x and g of x be the functions of x, and there is a condition is that when we take the limit as x tends to a and limit as x tends to a of f of x and g of x, it will get 0. Then we have to use the L'Hospital rule, guys. So let me write what is the L'Hospital rule. Then limit as x tends to a, here f of x upon g of x, that is equal to here limit as x tends to a, here f dash of x upon g dash of x. So where f dash of x and g dash of x are, where f dash of x and g dash of x are, these are the derivatives of f of x and g of x, guys. F of x and g of x. So this is all about L'Hospital rule. Now in this session we are going to discuss type number third, means indeterminate forms number third. So let's see indeterminate form number third. So which is this indeterminate form? So 0 into infinity, guys. 0 into infinity, this is indeterminate form. 0 into infinity. Now to solve this type of problem, means I wanted to write now here, to solve the problems of the type the problems of the type when limit as x tends to here a f of x into g of x, means we can write the fx and gx is in multiplication, means is in product. When when limit as x tends to a f of x, it will get the value is a 0, and limit as x tends to a here g of x, it will get value is a infinity, it will get value is infinity. So that is it takes form 0 into infinity, 0 into infinity forms, that is it takes the form 0 into infinity, guys. So we write limit as x tends to here a fx into g of x, means this is a product of two functions, guys, here. So that is equal to, this can be written as here limit as x tends to here a here fx g of x can be written as, now product in this case here fx into g of x, so this can be written as this is 1 upon g of x, this is 1 upon g of x, or sometimes I would like to also right now in this way, this is a limit as x tends to a, this will becomes g of x and divided by here also 1 upon here f of x, we can write now in this way. So therefore these new forms are of the type 0 by 0 or infinity by infinity respectively, 0 by 0 or infinity by infinity respectively, which can be solved by using, and therefore I am writing here which can be solved by using L hospital rule, guys. L hospital rule. So you know very well, if these examples we can convert it into 0 by 0 form or infinity by infinity form, then you will have to getting the idea how to solve by using L hospital rule, and this is a no, this is a no. I hope so you have to understanding this, what is this form and what we have to do here. So first of all, you do here the f of x into g of x can be written as f of x upon g of x or g of x upon f of x, means we have to make the form as 0 by 0 or infinity by infinity, that's all. And if we have to convert this infinity by infinity or 0 by 0, then it will get eligible to use L hospital rule and solve this type of example. Understand it? Let me start example on that forms, example on type number third. So I'm writing here example on type 0 into infinity, example on type 0 into infinity. Now let us take suppose first example. So problem number first, prove that limit as x tends to 0, limit as x tends to 0, x into log x, that is equal to here 0. We have to prove this. So let's see how it will be proved. I am taking solution is there. So let given limit as taking as L is equal to, this is a limit as x tends to 0, x into here log x, right? So you have to check, guys, you have to check if we replace x as 0 in this limit, means x as 0 into log 0, so it will get the form as, what is the form, log x means here means x into log x, means here x is replaced by 0, so 0 into log 0, 0 into log 0, it becomes infinity, log 0 becomes infinity form. I hope you have to understand this. Now What is your target? We have to convert it into 0 by 0 or infinity by infinity. Now, in a numerator, log x is there. So we have to just adjust x in denominator, guys. We have to just adjust x in denominator. Now this can be written as, this is L is equal to, this is a limit as x tends to here 0. Now this log x can be written as it is and divided by here 1 upon x. Now we have to apply limit, guys. Now we have to apply limit on this. If we apply limit on this, so numerator becomes here log 0, and log 0 it becomes, what is that here, infinity, divided by 1 upon 0. Here is also get infinity by infinity form. Infinity by infinity form. I hope you have to understand this. Okay. Now by applying these types of adjustment, so infinity by infinity form is there, and therefore by hospital rule, means by here L hospital rule, by L hospital rule. So what is that? It becomes, that is equal to, this is a limit as x tends to here 0. We have to take the derivative of numerator, guys. Derivative of numerator, it becomes 1 divided by x, and divided by 1 upon x, derivative it is minus 1 upon here x square. So by applying L hospital rule, we have to getting this step. We have to just evaluate it. We have to just evaluate it. So this is what I am writing here, limit as x tends to here 0. This can be written as, this is a minus of here 1 divided by x into here x square. So what we will get here remaining is, means limit as x tends to here 0. It will get here only minus x is there. It will get here only minus x. So therefore limit operate on this minus x. So what will get your answer? X has replaced as here 0. This is not 0 by 0 or infinity by infinity. Therefore we can directly apply limit on x. So this is, what is that here, 0. I hope you have to understand this very well. Next example I'm going to discuss to you. Now we are going to discuss problem number 2. Let's see what is the problem number 2. Prove that limit x tends to 0, limit x tends to 0, sin x into log x, guys, sin x into log x, and that is equal to 0. We have to prove this. So let's see how to write its a solution. So in this case, we have to just given to you product of two function, guys. In this case, we have to just given to you product of two functions. So that's why I am writing here, let given limit as L is equal to. So L is equal to, that is, it becomes limit as x tends to here 0, limit as x tends to here 0, sin x into log x. Nothing will do here, nothing will, we have to do extra here. So first you have to check, is it what form? Is it when we replace x as 0, so sin 0 becomes 0 and log 0 becomes here infinity, guys. Log 0 becomes here infinity. So therefore I have to directly here write the function as now in this way. This is a limit as x tends to here 0. Now this will get log x upon here 1 upon sin x. Log x upon here 1 upon sin x. And after that, guys, you have to also check here, when we apply limit on log x, that will get log 0. Log 0, it will becomes here infinity, right? Log 0 becomes here infinity, divided by 1 upon sin x, means 1 upon sin 0, it will get also infinity forms. And if there is an infinity by infinity form, you have to just apply directly here by L hospital rule, by L hospital rule. So by L hospital rule, what we'll get here, L is equal to, taking the derivative of numerator and denominator, guys. Take the derivative of numerator and denominator. Log x derivative is 1 upon x, divided by derivative of here 1 upon sin x, means 1 upon x derivative, that is a minus 1 upon x square, means here sin square x, into sin derivative of this, that is called as here cosec x, that is called as cosec x. I hope so you have to understand this very well. This is cosec x. Now we have to also evaluate now in this way, limit as x tends to here 0. So that can be written as, this is 1 divided by x, guys, upon 1 upon sin square. So instead of write, we have to write this is cosec square x, guys. This is a cosec square x. I hope you have to understand this. Just wait, I have to also here taking this term as now in this way, this term as now in this way. Just wait. Let this limit L is equal to limit as x tends to 0 log x upon 1 upon sin x. This can be also written as limit as x tends to here 0, that is a log x upon 1 upon sin x. It will becomes here cosec x, because cosec is a reciprocal of sine. Now we have to write now in this way. Now we check when apply limit, it is infinity by infinity form, guys. And now by using L'Hospital rule, we have to take the derivative of numerator and derivative of denominator is here. When limit as x tends to 0, so that you will get derivative of numerator log x derivative 1 upon x, cosec x derivative is there minus cosec x into cot x, minus cosec x into cot x. Now just you have to adjust here, just you have to adjust. So minus sign I am taking outside the limit as limit x tends to here 0, 1 upon cosec x it becomes sin x, 1 upon cosec x it becomes sin x. Minus is already I have to taken outside this limit, guys. Into what is remaining here, cot x. Cot x it is nothing but tan x, and this x divided by now here in this way. I hope you have to understand this, right? So therefore L is equal to here minus limit of minus limit as x tends to 0 of, we operate limit on both functions here. So here is what is that sin x into limit of here as x tends to here 0 tan x upon x, means this is a tan x upon x, and you know the formula for limit tan x upon x is 1. So what we'll have to remaining is here minus limit of x tends to 0 sin x value becomes, means sin x I am putting as it is now. Now inside this bracket you know the formula is very well. So since I am writing the formula limit as x tends to here 0, that is a tan x divided by x, so which is equal to what, guys? 1. So therefore we have to directly apply limit on this. We'll getting the answer limit L is equal to 0. We'll getting the answer limit L is equal to 0. I hope you have to understand this. Now let me discuss next problem. Let me discuss here next problem, that is a problem number 3rd. So what is the problem number 3rd given to you? Let's see. Prove that the limit as prove that limit as x tends to infinity here a raised to 1 by x minus 1 into x, that is equal to here log a. That is your question given to you. Now we have to solve this, we have to solve this. So let, in previous example we have to solve how to solve this example. Let we have to consider first given limit as L. So let L is equal to, what is this limit? Limit as x tends to here, what is given to you here? Infinity is given to you, guys, and a raised to 1 by x minus 1 is there into x. Now this can be written as into x, this can be written as, or when we are applying limit on this both side, when we are applying limit on this function, so what we'll get here, it takes the form here 0 into, instead of x we have to substitute here infinity forms, 0 into infinity forms, and let it confirm, is it 0 into infinity form? Yes, is it 0 into infinity form? So therefore this limit L can be written now is in this way, limit as x tends to here infinity, this can be written as a raised to 1 by x minus 1, and this x can be written as 1 upon x, guys. And now you take, or you have to observe here, is it which form? Now this is converted into simply here 0 by 0 form. Because of that when we substitute a raised to 1 by infinity, means x as infinity, that's why the numerator term becomes totally, what is that here, 0, and also denominator term is also 0, because 1 upon infinity your answer you will get 0 forms, 0 form. And if this takes 0 by 0 form, so then you have to directly use by L'Hospital rule, by L'Hospital rule. So by L'Hospital rule, it will becomes that is a limit as x tends to here infinity, right? We have to take the derivative of numerator and denominator, but before that we have to take some substitution is there, because here the numerator and denominator little bit in complex form. So that's why I have to write by putting here some substitution. 1 by x is equal to t, and when we substitute 1 by x, when we replace x term in t, then limits are also changes. When x tends to infinity, t tends to here 0. When x tends to infinity, t tends to 0. So therefore L is equals to limit as x tends to infinity, means now not x, because I had already replaced x as a t. So here t tends to here 0. A raised to 1 by x means what is that? T minus 1 divided by 1 by x is also called as t, and it will take now here 0 by 0 form. It will take 0 by 0 form also. You have to observe this, guys. A raised to 0 minus 1 means a raised to 0 is 1 minus 1, that is 0 upon 0. It takes 0 by 0 form. Now we are applying L'Hospital rule, guys. Now we are applying L'Hospital rule. So L is equal to limit as x tends to here 0, a raised to t, derivative of a raised to t, that is a raised to t into log t, minus 1 derivative it is 0, and t derivative it is 1. So therefore this is not, again you have to observe here, this is not 0 by 0 or infinity by infinity, not indeterminate form is their form. So that's why I am writing here, or I am operating directly limit. I am operating directly limit, and you will get what is your answer here. T means 1 upon x is again, so I am writing t tends to here 0, means a raised to 0 and log a is there. This is a log a. When we applying limit on this, it will get only the answer here, log a. I hope you have to understand this problem number third also. So we discuss number one problem, number two, and problem number three up to, that is only type is what? 0 into infinity, guys. Type is what? 0 into infinity. Now next we are going to discuss type number 4. Type number 4, examples on type number 4. So what is the type number 4? I am writing first type number 4. So type number 4 takes the form as here infinity minus infinity, infinity minus infinity. So in this type what we do here, guys, in this type what we do here, now let I am writing here in this type, to evaluate the type of limit, to evaluate the limits of the type, that is what is that? Infinity minus infinity means what is that here? Limit as x tends to here a fx minus g of x, when limit as x tends to a here fx, it will becomes, it's a limit as infinity, and limit as x tends to a g of x, it will take also infinity. That is which form? Infinity by or infinity minus infinity form. So that is infinity minus infinity form. Now we reduce the above expression, means we reduce the expression in the form of, in the form of 0 by 0 or infinity by infinity form, 0 by 0 or infinity by infinity. And by taking LCM, and by taking LCM, or rearranging the terms, guys, or rearranging terms, and apply L'Hospital and so to evaluate the limits of this type, by using now here L hospital rule. So what we'll do here, guys, what we'll do, so first you have to give an expression in the form of suppose infinity minus infinity form. Then you will have to convert into 0 by 0 or here infinity by infinity forms. And after that use LH rule, use LH rule. And when we applying LH rule, so what we'll do, in type number first, second and third we discuss here. By LH rule you will have to, using this rule you will have to solve here. And that is a procedure for type number 4. That is a procedure for solve infinity minus infinity problem by type number 4. I hope you have to understand this. Now let me start example on type number 4. Problem first on type number 4. Let's see. Prove that limit of limit as x tends to here infinity in bracket cos hyperbolic inverse x minus log x equal to here log 2. Now this is your question and you have to solve this. Now let me start solution. Let given limit I am considered as L. So let L is equal to, that is a limit as x tends to here infinity. So you have to observe, guys, what is the limit you have to use as x tends to infinity. You have to observe this very well. Now this is a cos h inverse x minus here log x, means cos hyperbolic x minus log x, and we have to prove after solving. Your answer is what is that here log 2. So let's see how it will be solved. We have to taking here LHS simply, and we have to prove the log 2. So simply what we'll do here, we have to do the first check, is it form or whether it is a form. When we replace x as infinity, means cos hyperbolic infinity minus log infinity, so it will take form, what is that here, infinity minus infinity form. So clearly in example or in LHS, which form is text, infinity minus infinity form is text, means this example are belongings to type number 4, guys. Now it have to convert into 0 by 0 or infinity by infinity form. So how will do convert here? So let's see. This is a limit as x tends to infinity. Now you know the formula for cos hyperbolic inverse x minus log x, cos hyperbolic inverse x minus log x. Now instead of this cos hyperbolic inverse x, we have to write here log of in bracket x plus under root of x square minus 1, means just we have to adjust this here terms, minus here log x, minus here log x. Now you have to also just observe here, so this can be written as, this is a limit x tends to here infinity log of, I am taking log of subtraction in above step. So here by using the property of log x, means log of a minus log b, this can be written as x under root x square minus 1 divided by here x. Because of that, this is a log a minus log b. We have to use this property. Now you have to check here, guys. Now you have to check it takes which form. When we replace x as infinity, it will get clearly infinity by infinity form, clearly infinity by infinity form. So therefore by using L'Hospital rule, we have to take limit as x tends to here infinity. This can be written as, this is log of 1 plus, that is under root of, I'm just separating the denominator, guys, separating the denominator. So this is what is that here 1 minus 1 upon here x square. And now you have to operate the limit and you will have to getting the answer is what is that, you will have to operating limit directly. Now this is not now 0 by 0 and infinity by infinity form will max, so that's why you have to operate limit directly easier. So what is that your answer, your answer is a log of here log of 2 is there, because of 1 plus that square root also you will have to getting 1, so your total answer will be log of 1, and hence the proof, hence the proof. You have to observe here what is the RHS. RHS is a log. Next problem we are going to discuss, that is a problem number 2. prove that limit as x tends to 1, 1 upon log x minus x upon x minus 1. So that is equal to minus 1 by 2. So we have to prove this. Now we have to take the LHS. So what is LHS, guys? So I'm writing the solution. Let LHS means I'm taking the limit as L, and L is nothing but here as x tends to here 1 in bracket 1 upon log x minus x upon x minus 1. When we replace x as 1, guys, when we replace x as 1, it takes the form, so which is a form here infinity minus infinity form, guys, that is infinity minus infinity form. So you have to observe this very well. Now therefore this L is equal to, I have to convert it into just 0 by 0 or infinity by infinity form by taking LCM or some other calculation is there. So now this adjustment is there. So x minus 1, I am taking the sum of 1 by log x and minus x upon x minus 1. This can be solved by using x minus 1. Means 1 into x minus 1, x minus 1 minus here x into log x, and total divided by, it is a product of x minus 1 into log x. So x minus 1 into log x. Now you have to observe. Now here you have to observe. Now we replace x as 1. Now we replace x as 1. It takes the form as now clearly here 0 by 0 form. 0 by 0 form. Now directly by applying here L'Hospital rule. Directly by applying here L'Hospital rule. So how to apply the L'Hospital rule is there. It is very easy to understand. So therefore by L'Hospital rule. So by L'Hospital rule, what you will get here? Limit as x tends to here 1. Take the derivative of numerator, it becomes 1. Now minus 1 derivative it is 0, x derivative is 1, minus 1 derivative is 0. Now this is a product of x into log x. This is a product of derivative. This can be written as minus x log x derivative 1 upon x minus here only log x, because x derivative is 1. So therefore this is in denominator also x minus 1 I am taking as it is, into derivative of log x is 1 by x. Now plus log x is there as it is. Now this x and x get cancelled here, and the remaining terms you will have to write here. The remaining terms you will have to write here. So therefore L is equal to limit as x tends to 1. So which are the remaining terms? So only 1 minus log x. I hope so. This is means 1 minus 1, that is also 0. That's why here minus here log x, and divided by what is remaining here. I am multiplying this 1 by x in this bracket, so this will get 1 minus 1 by x, right, plus log x. Now again you have to observe. Again I am observing this, it is again take 0 by 0 form, and if this is again take 0 by 0 form, again you have to taking the L'Hospital rule, guys. So therefore limit as x tends to here 1 minus log x derivative 1 by x divided by derivative of 1 0 minus 1 by x derivative minus 1 upon minus minus, that will be plus 1 upon x square, and plus log x derivative again 1 by x. Now you are able to apply directly limits. Now we are able to apply directly limits. So therefore limit as x tends to 1 means numerator becomes here minus 1 divided by denominator is 1 plus 1, that is 2. So therefore your final answer L is equal to what is that, minus 1 divided by 2. You check the RHS is what? You check the RHS is a minus 1 by 2, and LHS is also minus 1 by 2, and hence the proof. Hence the proof. I hope you have to understand this very well. Next, let me start third example. So this is very interesting problem. Now here I am going to discuss to you. Prove that limit as x tends to 0, limit as x tends to 0, a upon x minus cot of x by a equals to 0. Means you have to show RHS is 0 after simplifying this limit. Now let's see how it will be solved. I'm writing just a solution here. So let given limit can be written as L is equal to limit as x tends to here 0, a by x minus cot of x by a. You have to observe this very well, guys. When we replace x as 0, so it takes the form. So which form it takes? So it takes infinity minus infinity forms. Now next, putting x by a, that is equal to, I am taking some variable here y, when when x tends to 0, that will becomes y is also tends to 0. Means there is a simple trick for solution is there, guys. Means you have to just take the term x by a as y, because this is a little bit easy way to understand. The term is x by a is equal to y is there. Means for simplification we will have to do here for simplification. So therefore L equals to, that is limit x tends to 0, means here now y tends to 0. Now a by x, it is nothing but here 1 upon y. I hope so you have to understand this. This is 1 upon y minus cot of y is there, minus cot of y. So therefore this will take as a limit y tends to here 0. Now this is totally converted into y, so that's why I'm writing this now in this way. So this is 1 upon y, and cot y it can be written as 1 upon tan y. It is a reciprocal of tan y. I hope you have to understand this. So again it takes which form here, infinity minus infinity form. So therefore this will have to equals to, we have to solve this bracket as y tends to here 0. So what is that here? Tan y minus y, inside the bracket there is a calculation, tan y minus y divided by y tan y. So therefore this is equal to, this is a limit as x not y tends to here 0, tan y minus y, we have to just adjust here. How to adjustment is there? That is a tan y minus y divided by, here I am taking here y square, I am taking here y square, and into when we operate the limit on denominator, that is a y tends to here 0, into that can be written as 1 upon y tan y, 1 upon tan y upon y, tan y upon y. That is a little bit adjustment is there. I hope you have to understand this. I hope you have to understand this, because I'm taking y square is extra term, right? So for cancellation I have to take y is in also denominator. So therefore limit as y tends to here 0, this is tan y minus y upon here y square. Now into, what is the value of this limit y tends to 0, tan y upon y? That is value is 1, guys. This value is 1. Now we take 0 by 0 form. By standard limits, you know the value for this second limit, this is totally 1. So again it takes 0 by 0 form. That's why I'm taking again by using L'Hospital rule. So limit as y tends to 0, inside the bracket tan y derivative is, what is that here, sec square y minus y derivative is 1 divided by 2 y square derivative 2y. This step by using L'Hospital rule, L'Hospital rule. So I hope you have to understand this step very well. Now what is the next? I have to also solve here limit as L is equal to, that is limit as y tends to here 0, sec square y minus 1 upon 2y. I am writing here once again. So this is a sec square y minus 1 upon 2y. So it will take again 0 by 0 form. So by LH rule, we have to stop taking the LH rule until you not get the form 0 by 0 or infinity by infinity. Now here step by step we have to getting 0 by 0 form. That's why we have to again and again use the L'Hospital rule. So therefore this can be written as limit as y tends to here 0, inside the bracket, what is that, sec square y derivative of sec square y, it is a 2 sec y into sec y tan y, sec y tan y, and minus 1, that is a constant derivative here 0, and 2y derivative it becomes only 2. Now there is a no any 0 by 0 or infinity by infinity form. Now we have to directly apply the limit as y tends to 0, and your total answer you will becomes here 0. I hope you have to understand this. Hence true. Okay. In this session, we have discussed type number third and type number four, guys. I hope you have to understand this very well and enjoy the session. Now it is sufficient for today. Thank you.